Okay, we're going to have a look at statistics today. We're going to start as ever back at the National 4 level of statistics, just to make sure that you're happy with it before we look at the National 5. So just this first little bit will be your National 4 revision, and then we'll look at the National 5 level. Okay. So statistics is a branch of mathematics that deals with analysing information and data that are gathered from surveys or questionnaires or reports, and just having a list of that data isn't very useful, so we can use statistical analysis to work out different parts of it. The two different things that we usually look at when we're looking at data is the average, so what the most kind of common result is, and the spread, how spread out things are. Now at National 4 level you should have already looked at the mean, the median and the mode, which are three different types of average. To calculate the mean, you add up all the numbers and divide by the numbers of pieces of data that you have. That's what a lot of people refer to actually as the average, but it's actually only one type of average. You also get the median, which is the middle number when you have your numbers in an ordered list. And we have the mode, which is the number that occurs most often. Sometimes one measure of spread is better than the other. Generally speaking, the mean is the best one because it uses every single piece of information, but not always, as you'll see in the following example. Okay, so we're going to calculate the median attendance. Median is your middle number, but we must have our numbers in order before we calculate the median. So we need to put our numbers into an ordered list. So the smallest number here is 8,900. So we start with 8,900, then go to 9,700, 10,300, 12,700 and 59,200. Now to find your middle number, you are just looking for the number that is now in the middle. So here we've got 5 numbers, so the middle number is just going to be this one here. Now you see that splits my list exactly in half. I've got 2 numbers this side, 2 numbers this side, so that is my median. The mean, to calculate the mean, we add them all up. So we do 8,900 plus 12,700 plus 59,200 plus 10,300 and the last one's hiding from me, 9,700. Adding them all up gives me 1,00800. I've forgotten how many zeros that is already. 1,00800. And then we divide by how many pieces of information we've got. So that's 1, 2, 3, 4, 5. So we divide by 5 to get the mean, which is 20,160. Which of these two averages, the mean or the median, is more representative of the data? Now, in most cases, your answer here will be the mean because it's using every single piece of information. But for this one, it doesn't work because we have that large outlier of 59,200. 20,160, if you look at it in this ordered list that we've got here, sits here. So it doesn't really represent any of this data down here at all. So in this case, I would say the median. And the reason for that is because the highest number, because it's so much higher than the rest, because it's this big outlier, we call it, because it's so far away from the rest, it skews the data. Okay, and that makes the mean not as good a representation in this case as the median. So the median, because the highest number makes the mean too high to represent the data. Sorry about my writing on this. Better with my numbers, not so good with words still. Okay, So that's mean and median then. Let's see if we can include our mode and also range, see if we can remember what that one is. Okay, so our mean here, to find the mean, we're going to add them all up. 2 plus 6 plus 6 plus 1, 2, 3, 4 7s. 4 7s are 28. 3 8s, 24. 2 10s. Plus 11. Plus 13. Plus 25. We get 135. The symbol that we can use for the mean is x with a line above it, which is x bar. So we're going to do 135 divided by, does it tell us how many there are? No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we get 9. See, the mean's a bit better this time. Your 9 sits in there. So it's a bit more representative of the data. We still have quite a highest number that does skew it slightly. Obviously a teacher on this school trip rather than a student. Well, I don't think you'd get a 25-year-old student anyway. Okay, the median, the middle number. I'll just get rid of that line that I've just put in, because that will upset me finding the median. There are 15 numbers. Half of 15, 7.5. So we count in 1, 2, 3, 4, 5, 6, 7. I'm going to circle that one here. On the other side of that, 1, 2, 3, 4, 5, 6, 7. What you can also do, which I can't show you the way the software is set up, is you can count in one from each side, and work your way in. You've probably seen that way before as well. So our median here is 8. Your mode is the one that appears most often. Here I've got 4 7s, so my mode would be 7. Your range is a measure of how spread out the data is. So your range is the highest number, take away the lowest number, and again that is National 4 level work. Highest number is 25, lowest number is 2, so we get a range of 23. If we look back at the data that we've got, if we ignore the first and the last number, it goes from 6 to 13. So the ages weren't actually overly spread out, but a range of 23 suggests that the range is really high. Okay, now any of these averages would have worked out perfectly well for this question, but this range that we've used to calculate the measure of spread doesn't really help. Most of the children here were aged from 6 to 13. The Sunday school teacher's age 25 and her 2-year-old son gives this false impression of how spread out these ages were. So we need a different measure of spread. Okay, and it takes into more numbers than just the highest and the lowest. And that measure of spread we're going to look at is called the semi-interquartile range, which we'll shorten to SIQR. Okay, in your semi-interquartile range, we need to work out quartiles. Okay, so quartiles, exactly what they sound like. If you quarter something, you're working out the quartiles, you're splitting it into 4. So when we work out the median, we split a list in half. When we work out quartiles, we split it into 4 equal bits. And we do it by starting to find the median, which we can call Q2. We can then find the middle of the lower half of the number, so just like finding the median again, and we call that Q1. And we can do the same for the top half of the numbers, and that gives us Q3. So 2 types of range then. We get the interquartile range, which is Q3 minus Q1, and the semi-interquartile range, which is a half of Q3 minus Q1. You will not get given these, but you are expected to know them. Okay, let's do a couple of examples then. So this is still the same set of numbers that we had before. I'll just double check that it is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep, still 15 numbers. Half of 15, 7.5, which would be my 8th number along. So 1, 2, 3, 4, 5, 6, 7. My 8th, that's going to be my Q2. And you see this splits the list exactly in half. It's hard to tell when you've got single digits and double digits, but do it by counting. 1, 2, 3, 4, 5, 6, 7 that side. 1, 2, 3, 4, 5, 6, 7 that side. So my median, Q2, is 8. I then want to do the same again. So now on this side, for my Q1, I've got these numbers. And I want to split these exactly in half. Okay, so we don't worry about the number 8. I've taken it out from the list, that's why it's got a circle around it. So I've removed it from the list. Split these in half. There's 6 numbers. Now there are 7 numbers. After that 7.5, so it's my 4th number along. See, that gives me 3 numbers each side. So that gives me my Q1. So Q1 is 7. Do the same the other side. Here we're going from this 8 to this 25. So again, 7 numbers. And that gives you my Q3. Okay, which is 10. So my semi-interquartile range is a half of Q3 take away Q1, which is a half of 10 take away 7. 10 take away 7 is 3. Not where I wanted my 3. So it's a half of 3, which is 1.5. And you see that as a measure of spread is 1.5 of a difference between is a lot more accurate than the 23 we got just from working out the range. Let's try a second example then. Okay, I'm just looking at the time here. I might be able to get a couple of these done and then I'm going to start a new video. So do you know what, I'm going to stop there and I'll do this next example in the next video.